while ago I bought from the Canadian government a box full of dosimeters, and there were 7 of these in there, plus some different types. So what I'm going to do is tear one of these apart. It's actually going to be this one, since it's damaged here, and it also looks like it took some maybe leaky battery in there. But these 4 kind of work. At least the display's coming up. Oops. And stuff moves around. I've downloaded the manual, so I'll take a look at it. What these have is 3 sensors in them. 3 active silicon diode detectors. Down here is for beta. For here is making noise, meaning a piezo. Menu switch. Battery compartment. It takes a single AA battery. And then this seems like the most common fail point is right there. Is these plastic parts breaking off in here. Let's see what else. Oh, if you're looking for these on the internet, Siemens sold their division for this product back in 2003 to Thermoelectron Corporation. I was looking at my cheat notes. Let's see what else to say about it. It reads gamma rays, X-rays, beta from 250 kiloelectron volts up to 1.5 mega electron volts. The radiation stuff, 15 kiloelectron volts up to 10 mega electron volts. So it's time to pop this thing open. Well, this is probably going to be fairly destructive. So, looks like the top part here pops off in one way or another. There we go. So that's what that looks like. Yeah. Oh, this looks like it's going to be easier than I thought. Famous last words. Make sure I stay in focus. Well, oops. Let's see if I can. Oh. There we go. And I thought this thing was going to be welded shut. There. Now, try to stay in focus. Don't see anything attached. Try gently. Okay, I'm just going to have to pull this to the side. Looks like I need to come in from down here. There we go. If a delicate touch doesn't work, get physical. Okay. There we go. We're in, kind of. Okay, so there's the infrared. It's got the receiving and the transmitting in here. I didn't even realize it had that. This is that standard, it's not mica, So they've done something different on this one. A comment I saw in one of the papers on these was issues with just normal EM, like radios, radars, etc. So it looks like they've heavily encased it all, except for where the beta has to come in. So I'm just going to take a look at this to see how I get in here. It sure looks like they actually welded the seams. So there's only one way I'm going to get into this, and that's cutting. It also looks like on the back here, looks like there's possibly some diodes here. And I'm wondering if there's also some infrared diodes here. I didn't see that in the manual, but the manual is on one of those, hey, we own the manual because we've got a copy of it. So I'm going to start cutting. Maybe. Not sure how this is going to work. Okay, there's a bit of a break in it. Oh yes, I think I'll just be peeling it off. Oh, yes, make sure camera's still going. I've had so many problems with that. Let's see if I can get a... Oh, okay. Interesting. Well, I'm just going to keep peeling away and hope. Well, that became a lot quicker. Okay. Nope, not yet. Detach that. Trying to make sure I don't cut myself. Maybe I should have picked one that the battery hadn't leaked. There we go. Part way. Hopefully that's still in there. Now there's where it connects to the case for grounding. Or shielding in this case. Okay, I'm going to zoom in on this. There we go. And then I'm going to take a short break. So here's a close-up. Right here we have an NEC D78 P064 GC 8-bit single chip microcomputer. There's 32 kilobits of program once ROM. There's a 40 by 4 bit LCD RAM, and then there's 1024 bytes of high-speed RAM. Oh, and here's one sensor, here's the other sensor, and then over here somewhere is the other sensor. And I'll be tearing these lids off after I've gone through the components. This here is an 25320 SPI serial EEPROM 4K by 8-bit. So obviously helping out that. Over here, we're getting into the power side of it. It's a Max 761 ESA. The ESA stands for minus 40 centigrade to 85 centigrade. It's a 12 volt, 15 volt or adjustable high efficiency step-up DC to DC converter. Keep in mind the DC to DC converters because there's more than one on this one. Okay, then we got inductors. Some transistors down here. All this stuff's tiny. Okay, I'm going to flip this over now. And put a weight on it. Oops. You can take a guess. I've got the camera right up to this thing. Okay, on this side, we have the mystery one. Found lots of references to it. The CLT 83040CW. Couldn't find the specs on it. I'm kind of wondering if it's leading up to this here, going to the LCD display. And if I'll quit bumping the thing. Then over here, we have a 32.768K. It's a crystal oscillator. And beside it is a 867 EUA. I'm not 100% sure, but I'm pretty sure that's a Max 867. And that's a 3.3 volt to 5 volt or adjustable single cell DC to DC converter. So hence, the battery, wherever it is, would have been up here, is then feeding this one, which converts it to a higher voltage, which throws out. And then there's on the other side, another one converting it to a higher voltage. And over here, oh, there we go, is a Max 934 ultra low power comparator with a 2% reference. And then lots of other little stuff. So the next step is pretty sure these are infrared receiving diodes. There, and these two are the transmitters. I couldn't find any reference to this, and I kind of think because they're actually mounted, let me grab it, literally underneath the holder, like the clip, that these are for the manufacturing. But that's a guess, so I don't know. So next we'll be tearing open these cans. And I expect to find the silicon diodes for the detectors in there and probably preamps, boosting it up to get it out to this area. Just before I started to cut into this, I noticed here, it looks like it's an LED. And there's a tiny hole in the shielding here. And also over here. I kind of wonder if this is a self-check system, so that what they can do is, if you push the test button, these LEDs light up. The photo silicon diodes are in here. They obviously get a whack of light, and hence would probably go very high for reading. So they don't need to actually have a radiation source to check to see if the photodiodes are working. But that's just my guess. Now I'll chop into it. Okay, let's see what happens. This should be interesting. That actually came out pretty good. Well, there goes part of the window. Try to keep it in focus. There's our silicone or silica. Come on. Obviously I can't talk and work at the same time. Okay, lots of sharp edges in there. I'm going to put this down and then zoom in. So there's the heart of it. You've got one detector here, one silicon diode detector here, and a third one over here. And apparently they use all three for determining the reading. Notice there's also, if I can get this, there's another LED, and there was a little tiny hole there. Ditto and ditto. So that was most likely for the testing. And we have the transistors in here for boosting the signal before it comes out of this shielding. The shielding's to keep out ambient light, but also I saw in the papers I read on this is initially they had issues with just normal electromagnetics, so like radios and radars. So I suspect that's why this thing has been so heavily shielded. But that's kind of cute. And this video is getting way too long. The sad thing is, and I'll just pull this out for a second. This metal here, I had hoped they'd use tin so I could make a tin hat. No, it's magnetic. Damn. Oh well. Have a good one. Bye. Dope! I forgot to show the other side. There's a big chip in there, 93 AFTYJ. I couldn't find any reference to it, other than some studio. Oh well. So that's what's underneath the other side, and of course that was heavily EM shielded. So now, that's it. Have a good day.